Media queries only target the global viewport size. This fundamental limitation breaks component portability across different layout contexts. Imagine placing a wide card component into a narrow sidebar. The component needs to adapt its internal layout based on the sidebar width. Standard media queries cannot provide this component-specific breakpoint. They only react to the browser window size. This forces developers into complex JavaScript solutions or excessive utility class management. This is scope leakage, where component styling depends on external page layout. Container queries solve this critical scoping issue immediately. Container queries allow components to define breakpoints relative to their immediate parent container. This ensures true component encapsulation and portability. Components can now adapt their styling based on the available space they actually occupy. This eliminates the need for global breakpoints inside component code. This is the paradigm shift we have been waiting for in CSS. We can finally build truly independent, responsive components. Container queries require defining a containment context on the parent element. Use the container shorthand property for this definition. The syntax is container name/type. The container type property specifies which dimensions are queried. Inline-size queries the horizontal dimension, which is the container's width. This is the most common and recommended choice for component adaptation. Using size queries both the width and the height dimensions. However, size imposes stricter layout constraints on the container element. The normal type establishes a query context without imposing any layout or size containment. Use container name when you are nesting multiple containers. Naming is also necessary when targeting a specific ancestor container. Defining the context is the essential first step for enabling component responsiveness. Always start with inline size for maximum flexibility. The query syntax uses the new @container rule in CSS. This structure mirrors the familiar syntax of the @media rule. The rule applies styles specifically to descendants of the defined container. Styles are applied only when the container meets the specified dimension criteria. For example, use @container minimum width 400 pixels to set the condition. The styles inside the block apply if the container is 400 pixels wide or wider. Container query units provide true component encapsulation. Units like container query width represent 1% of the container query width. Similarly, container query height represents 1% of the container query height. These units allow sizing elements relative to the container's dimensions. Crucially, they do not rely on the global viewport size. This ensures that component sizing remains entirely scoped to its parent. Remember to use standard CSS properties inside the query block. Let us implement a responsive card component using container queries. First, define the parent element, the card wrapper. Set the wrapper property to container type inline size. The default card layout will use a vertical stack display. This is suitable for narrow spaces like sidebars. Now we apply the container query rule. Use @container minimum width 300 pixels to define the breakpoint. Inside this query, we modify the card's internal layout. Set the card display to grid and define columns. Use grid template columns 1 fraction, 2 fractions for a side-by-side layout. When the wrapper exceeds 300 pixels, the card instantly switches to the horizontal grid. This adaptation happens regardless of the viewport size. The card maintains optimal readability in both narrow and wide contexts. This ensures true component portability across any layout structure. Defining a container query context implicitly sets the CSS contain property. When using container type inline size, the browser applies contain layout inline size style. This specific setting is crucial for performance and stability. It prevents the container size from being affected by its content's layout changes. This containment only applies along the inline axis, typically the width. Using container type size implies a stricter setting. It sets contain layout size style. This requires the container to have a fixed size in both width and height dimensions. Applying size often breaks standard flow content behavior. If the container height is not externally defined, the content might overflow. Always prefer inline size for horizontal responsiveness. Only use size if vertical resizing is strictly necessary and externally controlled. A critical hurdle in container queries is preventing circular sizing dependencies. This occurs when the container size depends on its content. Simultaneously, the content size depends on the container query result. For example, if the container uses width auto, its width is determined by its children. If the query then changes the children's dimensions, an infinite loop occurs. Browsers mitigate this by ignoring the query or failing to establish containment. To avoid this, the container size must be defined by external factors. Use grid tracks, flex items, or viewport units to set the container size. Ensure the container size is fixed before applying container queries. The query must modify the content, not the container itself. This separation of concerns is mandatory for stable component behavior. Define container dimensions explicitly. When a component is nested within multiple container query contexts, scoping is crucial. By default, the component queries the nearest ancestor container. This behavior is usually sufficient for simple component nesting. However, targeting a specific non-immediate ancestor requires explicit naming. Define the outer container using container name main layout. Define the inner container with a different name, perhaps container name widget area. The component then uses the name within the query rule. Use @container main layout minimum width 800 pixels to scope styles precisely. This ensures the component reacts only to the main layout size. Unnamed containers are useful for single-level containment scenarios. Named containers prevent ambiguity and ensure predictable styling in complex layouts. Always name containers when you anticipate deep nesting or specific targeting needs. This maintains component integrity. When a component is nested within multiple container query contexts, scoping is crucial. By default, the component queries the nearest ancestor container. This behavior is usually sufficient for simple component nesting. However, targeting a specific non-immediate ancestor requires explicit naming. Define the outer container using container name main layout. Define the inner container with a different name, perhaps container name widget area. The component then uses the name within the query rule. Use @container main layout minimum width 800 pixels to scope styles precisely. This ensures the component reacts only to the main layout size. Unnamed containers are useful for single-level containment scenarios. Named containers prevent ambiguity and ensure predictable styling in complex layouts. Always name containers when you anticipate deep nesting or specific targeting needs. This maintains component integrity.
Container queries are now supported in all major evergreen browsers. This includes Chrome version 105 and newer. Firefox version 103 and Safari version 16.0 also provide full native support. For environments requiring graceful degradation, use the @supports rule. This feature detection mechanism checks for native container query support. Use @supports container type inline-size to wrap your container query styles. Older browsers will simply ignore the contain styles. For environments demanding full functionality, the official CSS Container Query polyfill is available. The polyfill uses JavaScript features like resize observer and mutation observer. These monitor container dimensions dynamically. Be aware that implementing the polyfill introduces necessary JavaScript overhead for compatibility. Native support is always preferred for optimal performance. Container queries establish the foundation for truly encapsulated component styling. They integrate effectively with existing CSS custom properties. You can set dynamic custom property values based on the container size. For example, set a padding variable larger when the container is wide. This allows fine-grained control over component appearance based on context. Future CSS specifications include the powerful concept of style queries. Style queries will enable querying custom property values directly on the container. Imagine using @container_style theme dark to apply dark mode styles. This eliminates the need for JavaScript class toggles to manage component state. State management moves entirely into CSS for enhanced performance. Style queries will allow components to react to external state changes without relying on DOM manipulation. This significantly improves maintainability and reduces complexity. Container queries are the first step toward this fully declarative component styling future. This integration unlocks unprecedented styling power.